Five out of 12.
Well done. 5 out of 12. So it's written in a very different way. It's the exact same idea. So now let's go back to this. Okay, tell me what you think about this part A. It's a bit strange.
Um, hmm, Confusing.
So
So that'd be one tails.
yeah.
It'd be like two ads, two tails,
Mm-hmm.
add, three tails, four add, four tails, five add, five tails.
Tails and 5 head, 5 tails. That's it. What is the probability that she'll get a 1 and a head? She spins this once, she flips this once. What's the probability she gets 1 and a head?
One out 10.
Well done. Yeah, basically 10 possibilities in total. So total outcomes is 10, and there's one successful one, 1 and a head. And any idea why are there 10 outcomes in total? Was there any way to know that without listing them all?
Because there's two sides on a coin and there's only five things on the spinner.
And how do you combine 5 and 2 to get 10?
Times it.
That's it. And so that multiplying the total outcomes for each thing will give you the total outcomes. Okay. I think you'll be fine there. Okay, let's try these.
Подожди секунду.
1 and 6.
Yeah.
Three out of 6.
Well done.
Then 3 out of 6 again.
So less than 3.
2 out of 6.
Yeah.
And then 0 out of 6.
Yeah. 0 out of 6, and it's fine to just say 0 because those two are the same thing.
Yeah.
0 out of 6 is correct as well. Okay, let's try this one.
Seven out of 20.
Yeah.
9 out of 20.
Well done.
And 0.
That's it. So this B is the important one. The probability of getting a lime is 11 out of 20. So you knew like 11 plus 9 makes 20. The way to do it in terms of probability is 1 minus. So if you do 1 minus lime, which is 11 out of 20, you get 9 out of 20. Basically they add up to make 1. And so you can do 1 minus to calculate the answer if you can't figure out what you have to add. So that becomes more important later on. Okay, any idea how you do this?
Um, 30 times.
What if the probability was 0.5?
Oh, that'd be 250. Would it?
If it was 0.5?
Yeah, I think so.
So half the time it lands on 5, half the time it doesn't. If the probability is 0.5.
Oh no, it would be 200. Sorry, I thought I said 500.
Ah, okay. If do you have a calculator on you?
Yeah.
So you've got 400 and 0.5. What operation goes in the middle that would give you 200? And you can try some stuff on the calculator if you need to.
Divide.
So put in 400 divided by 0.5.
Oh no, that's 800.
So that doubled it.
Times.
So try times.
Yeah, it's times.
So for these, 400 is the number of trials. So it's the trials times the probability. And that gives you this 200, that's called the relative frequency. So basically how many times it will happen. Frequency is how frequently something happens. So what would you put into calculator for this question?
400 times 0.3.
What's the answer? $120. That's it. And so 0.3 is the same as 3/10. So 3 out of every 10. So 1/10 would be 40, 3/10, 120. And so if the probability is 0.3, 400 times 120. Any questions there?
No.
Okay. And trials times probability equals relative frequency. Now try doing it without a calculator. Let's try this one, non-calculator. How do you do it?
So that'd be 300 times 0.7.
And can you do that without a calculator?
No.
So what might help is 300 is the same as 30 times 10. What is 10 times 0.7?
7.
Yeah, and so it's 7 times 30. And if you're not sure, you can do the same thing again. You can split it up.
Yeah. That'd be 210.
Well done, 210. And so it helps when you have these big numbers if you split it up to 10 and something. Just to make it so it's not a decimal. And then, well, 3 times 7 is 21 times another 10, 210. I'll skip that one. Okay. No, hang on a second. Any idea what the probability for pink is for this one?
So, 0.3.
Correct. They have to add up to 1. Brilliant. So they use bigger numbers, but it's the same idea. How about these two questions?
0.2.
Okay.
And then 3.
So
Sorry, carry on.
So there are 50 counters in total. 0.3 are green. And so you have to say how many are green. Any idea how you do that?
Oh, I didn't see how that contains 50 counters, but so so he's figuring this out. 6, 1.
Sorry?
15.
Brilliant. Yeah. So this is just like the other one in disguise. 50 times 0.3 gives you 15.
Mm.
So it's just like those other ones where you are, there's 50 in total, times it by the probability, and you get the relative frequency. 15, 0.2. Any questions about that one?
No.
Okay. How would you do just part B?
%.
They want how many, so 20% is correct, but they want how many red counters there are.
10.
Correct, 10. So it's basically 20% of 50, or 2/10 of 50, or 50 times 0.2. Same thing. Okay, you got it. I think you'll be fine for those. I think you have the idea. You can see there's more numbers, there's bigger numbers, but it's the exact same. This one's a calculator one, which will make it even easier. Okay, how would we do this one? There's 2 missing, and the question tells us number of white counters is the same as the number of black counters.
0.25 each.
So that would be if everything else was a half. So all 4 have to add up to 1. So any idea there?
No.
What do the red and blue add up to?
0.7.
And so what do white and black have to add up to?
2.5 each.
Just
Or
not,
0.25, sorry.
not each, just in total, what do they have to add up to? If these two are 0.7.
Add up, so.
Sorry?
So if you want to think about 0.5 as a 3, so we'd have to add up to 1.5 each.
Very close. So in total 0.3.
1.5?
Are you saying 0.15?
Yeah.
Yeah, that's it. Yeah, sorry, that's 0.5. So those two are 0.7.
Thinking that as a 3.
Alright, yeah, I was wondering why. Hang on. No, let me try. Okay, how about this one?
No. The probability for number 4B is 0.2.
For what, sorry?
The 4 question A,
Yeah.
would that be 0.2?
So what do the others, the ones that you know, add up to?
0.3.
And so what do the other two have to add up to?
3.5 each.
Not each, just in total. What would those two have to be?
Or 0.7.
So if each of them is 0.7, sorry, if in total they're 0.7, what is each of them? Or how do you figure it out?
Oh, I get it. So that'd be 0.35 each.
Correct. Yeah. And so you just half it because there's 2 of them.
Yeah, I keep on receiving questions.
Okay, so this time they use an X. Very similar idea though.
Yeah.
What will this be?
So that would be 0.25 each.
Say it again.
0.25 each.
That's it. 0.25. Okay. So you're good for that. So that's just the same idea, different numbers. Okay, tree diagram. Let's see if you already know. How does this work? How do we fill in this diagram?
So that's confusing me, so...
Well, so Hannah plays 2 games. She plays badminton first and tennis second. The probability she wins at badminton is 9 out of 10. What's the probability she doesn't win at badminton?
1 out of 10.
Yep. Okay, how about this tennis here?
3 out of 5.
Well done. And any idea about what goes in these two?
Would it be like something out of 5?
Yeah. And so basically you can see how it's tennis again. It's just that it's
so
just
that would be 3 over 5 for the first bit and then 2 over 5.
the first bit is that she wins.
Yeah. So would that be 2 over 5 again?
Yeah.
And then 3 over 5.
That's it. And so basically if she wins or loses badminton, it's not affected. It doesn't affect her tennis game. And it's just simpler to write it out twice. So the exact same thing twice. Any idea how you do this one? Work out the probability that she wins both matches.
How would I do that? Probability. Would that be 4 out of 10?
So I maybe should have looked at this earlier. Basically, the probability of both and you multiply, and
So,
the probability of either or you add. And so this is the probability that she wins both badminton and tennis. So what would you do there?
4 out of 10.
What's the working out for it?
What for the wins, but
Yeah. What's the method mark, or what would you put into calculator to work out the probability she wins both matches?
So would it be? Are we pricing it at times now?
Well, that she wins both badminton and tennis.
Yeah.
Is that multiplying or adding?
Times in, so that's 2 times 2.
So yeah, it's correct times in. And so this is Hannah wins badminton, and this is Hannah wins tennis. So what are the two probabilities that you have to multiply together?
9 times 2.
Yeah.
That's 18.
Yeah. And what else?
Do we do for 10 and 5 bit?
Yeah, so it's 9 out of 10 and 2 out
Ah,
of 5.
50.
That's it. So it's 18 chances out of 50, basically, or probability 18 over 50. Yeah, so, and you'll notice as well, another way to look at it is these diagrams, you add and subtract up and down, and you multiply across. So you add up and down, you multiply across. Basically both and you times, either or you add. Any questions there?
No.
Okay. So let's try this one. It's similar. This time they're decimals.
So for the first bit on does not win for Hoopla, would it be 0.6,
Well done.
0.7, 0.3, 0.7?
Well done. Okay, how about part B?
Point 0.4 to 0.3. 0.12.
Well done. Perfect. Oh, you got it quickly. 0.4 times 0.3, 0.12. Got it. Okay. Let's try the tricky type now. So there's kind of a trick to this. Okay. Try this.
So that would be 3 over 8.
Yeah.
3 over 7 and 4 over 7, 3 over 7.
So the trick to this one is
Oh wait, that's... So that would be... Oh, I get it, so it would be 2 over 7.
So this one down here is 2 out of 7. How about this one here?
3 over 7.
So this one up here, the 3 out of 7.
4.
So he had 5 reds out of 8. When he takes a red, there's now 4 reds out of 7. This one down here, he has 5 out of 8 reds as well, and he takes a green. So how many reds will be left, and what will be the total?
That'll be 4 reds left.
Well, he had 5 to begin with.
Because...
And he takes a green this time.
Yeah, so that would be 4.
He had 5 reds and he took a green. How many reds?
So 5.
Yeah, out of
7.
That's it. The total went down by 1 because he took 1 green. And so that's how this one works. This is called conditional probability. So it's as difficult as it gets. Okay, you have to work out the probability that he takes marbles of different colors. Any idea how you do that?
Yeah. So can I go to a minute?
Yeah, okay, yeah.
Yeah. Yeah, so would it be, how do we get them again? Don't we add up like, no we
Uh,
can't.
yeah.
Would it be 20 something?
Um, the
No.
probability that he takes marbles of different colors.
Yeah.
What way could you get 2 marbles of different colors? So you pick 2 marbles.
Mm-hmm.
How could you get to? What are the possibilities of getting 2 marbles of different colors?
Oh. 50-30.
I mean, like, so
50.
you could take like red then red. That wouldn't work. That wouldn't be a successful outcome. What would be a successful outcome?
Red then green.
Yeah. Okay. So what is the probability of a red then a green?
Would it be 30-50? 50-30 or?
What's the probability that you get a red on your first marble?
5 out of 8.
And what's the probability you get a green after that?
3 out of 8.
So it's here. So a red and then a green.
3 over 7.
That's it. 3 out of 7. And what's the probability of getting both red and green? What do you do?
Do we add them up 4 times and?
Which one? For both red and green.
Yeah.
Is that add or times?
Times?
Yeah, both and your times.
So 15
Yeah.
and 56.
Well done. There is another possibility. You could get a green and then a red. So that's another way you could get to get 2 different colors.
Mm-hmm.
And so what would that probability be?
Wouldn't that be the exact same 15 over 56?
Yeah. And so how would you get the probability, like total probability?
Okay.
Either red and green or green and red.
So, say that again.
So it would be the probability of getting either red and green or green and red. Total probability.
15 over 56 and 15 over 56.
Okay, so what would be the total chances?
Do we times them both again to get it?
In this case, it's not both and, it's either or. Either red and green or green then red.
Okay.
And so what do you do if it's either or? I'll go back. I don't think you've done this bit here.
It's I wouldn't add it.
Yeah. So basically you have 15 chances of red and green, 15 chances out of 56 of green and red, and so you get the total by adding them. And so what's your final answer?
30 over 112.
How do we add fractions? What do we do with the denominator?
We keep it the same, so that'll be 56.
Yeah. And so this is why at the start we practice the adding, the multiplying, all that. Yeah, or you could have doubled 15 over 56. You get 30 over 56, same thing. Any questions there?
No.
Okay, so that's the hardest type. We did that. I don't think we'll have time for to practice any more of those, but there's one more where you don't even have the diagram. But anyway, yeah, so this one you were fine for, so let's do a recap. This one you're fine. This one here in its simplest form, so that's 6 over 12, and if you simplify that you get a half. I skipped this because with probabilities you don't simplify it down. You just leave it as 6 over 12. Any idea why that is?
Because it's more complicated, or
Remember that one where we had 15 over 56 plus 15 over 56? If you had something like 5 over 12 plus 3 over 12, something like that, if you simplify one of them, then the denominators will be different. And because sometimes you have to add the fractions together, we just leave the fraction as it is so that they'll all have the same denominator.
yeah.
And so with probabilities, you just leave it the same. Yes, so for fractions, you have to get a common denominator to add them. And that's why we said 1 over 3 is same as 4 over 12, and then you add them. This was similar. 5 over 6, same as 10 over 12, and subtract them. Yeah, so the way probabilities work is your chances of it landing on A are literally 3 out of 8. 3 chances out of a total of 8, and that's 3 over 8. And you can write that as a decimal, 0.125. You can write it as a percentage, 12.5%, but it's exactly the same idea. Literally 3 out of 8 is the easiest way to look at it.
Yeah.
This one, yeah, it was 1 out of 10 because there's one successful outcome out of a total of 10 outcomes. So these you were then quite good at. So this was the important one, 1 minus, we'll leave that. Yes, so this one here, number of trials times the probability gives you what's called the relative frequency, or the expected frequency, how many times you expect it to land on that thing, or how many times you expect something to happen. And sometimes it will look a little different, but it's the same idea. So here it looked a little different, 0.3, 50 counters in total, and so 3/10 of 50 is 15. So the same idea. What do all probabilities add up to?
1.
Yeah. How do you find a probability if there's 2 missing and they have the same?
You add up for 2, you add up for numbers you do have, and then you pretty much see what numbers fit together to make the number that's missing.
Right.
Something like that.
Yeah, that's an example of the 1 minus 0.7 gives you 0.3. You just kind of knew it was 0.3. And then why was the answer 0.15? How did you go from 0.3 to 0.15?
I halved it because there's 2 gaps.
That's it, and they're both the same. And these look similar. And then tree diagram. What do these 2 probabilities have to add up to?
10.
Well, 10 out of 10, which is the same as? Or 10?
1.
Yeah, 1. 10 divided by 10, 1. 5 divided by 5, 1. How would you get the probability that Hannah doesn't win both matches?
I don't know. No, I don't know.
How did we get the probability that she wins both matches?
Um, I don't know.
How did we get the 18 over 50? Where did that come from?
I don't know.
So it's basically, if you want the probability she wins both matches, you you multiply the probability that she wins one times the probability she wins the other, both and your times. And so what would you do? What would you do to work out the probability she loses both matches?
You divide them.
No, just multiply the probability that she loses one match times the probability she loses the other. So same thing. So if you have to find the probability of both one thing and another thing, you multiply. If it's either one thing or the other thing, you add. And when you multiply probabilities, what you'll find is you always get a smaller number. That's what happens when you multiply fractions or decimals. When you add them, you'll always get a bigger number. And it kind of makes sense, because what's the probability of winning 2 matches, 3 matches, 4 matches? It should be more difficult, and so this probability should go down. Whereas what's the probability of winning any match out of 10? The probability should increase the more matches you play. Eventually you'll win one game.
Yeah.
And so that's where that comes from. And we did fractions and decimals for that. Yeah, how was that for you, Dylan?
Good.
Anything in particular you want to do next time?
No.
Okay, so I might extend this into Venn diagrams. Anyway, yeah. Any questions for me in general?
No.
Okay. Well done, Dylan. You did great. I look forward to talking again next week.
Same.
Have a good week. Goodbye.